Hello everybody and welcome to today's presentation, Real-Time Visualization of Software Value Streams, brought to you by CloudBees. I'd like to introduce you to our presenter. Ben Williams is a Senior Director of Product Management at CloudBees, where he focuses on continuous delivery and value stream measurement and optimization. Prior to joining CloudBees, he was a Product Director at Temenos, where he led an organization-wide DevOps transformation. His background is in complex systems and software development and product management, spending many years at IBM helping numerous automotive, aerospace, and medical device manufacturers transform their engineering groups across aspects of people, process, and tools. Well, without further ado, I'm going to turn things over to Ben to begin the presentation. Ben?
Thank you very much, Ryan. Hello, everyone. Thank you for joining us today for this CloudBees and DZone.com webinar. My name is Ben Williams. I'm part of the product team at CloudBees. I'm also joined by one of my colleagues, Karan Mahi. He's also part of the product team here. Today, I'm going to talk to you about how real-time visibility across the end-to-end flow of software value in your organizations is critical in helping you innovate faster. Before we start, I'd like to take a quick poll to better understand who you all are. The guys at DZone will open up a poll in the GoToWebinar session for you to answer. There's going to be a few polls like this throughout the presentation that will run in the same way. Just hang on a few moments while the results come in. Great, thank you very much. Okay, so it looks like a pretty good mix of different roles across the organization. Excellent. So, Mark Andreessen famously said that software is eating the world. You may have heard the mantra that today, to be successful, every company must be a software business. Now, I think that's partly true, but more accurately could be stated that every company must be a software and data business. Regardless, the statement has a lot of merit. Today, the primary source of innovation in the world is via software. Software we see taking over countless industries. It's had increased importance in our lives for quite a while now. If we look at the world's biggest companies by market capitalization, then back in 2007, none of the top 5 were software companies. By 2010, Apple and Microsoft had entered that top 5. And as of Q4 in 2017, all of the top 5 biggest companies in the world by market cap were software companies. That's quite remarkable. I don't expect that it will change anytime soon. And it's really amazing here with which the pace this shift has happened. We see that market after market are being disrupted. It's happening across transportation, across travel industry, watches, the automotive industry, and so on. Software is truly eating the world. Across the board, we're seeing that maverick companies are emerging and using software to challenge the established leaders and redefine a new baseline for their markets. Now, the key to rapid innovation through software is in continuous delivery. Continuous delivery is the secret sauce that allows you to innovate faster. When you have long release cycles, as has traditionally been the case with non-agile methods, every release includes a lot of change, and it has high levels of cost and risk as a result of that. Typically, each release is difficult and often quite painful. And when releases are big, when they're slow, when they're costly, when they're painful, at first it really does seem counterintuitive to release more often. But with continuous delivery, the risk, the cost, and subsequently the pain of every release is smaller. And with the amplified feedback loops that are enabled, the rapid learning cycles allow a much faster rate of innovation. But the amazing thing, I think, about DevOps and continuous delivery is that moving faster is just not at the expense of quality or reliability or resiliency or security. What you're seeing in this picture is what Jez Humble calls the iron triangle. It's the traditional project management trade-off between cost, scope, and time that needs to happen to maintain a desired level of quality. So if you increase scope, then cost or time will increase. Otherwise, quality will take a hit. If you decrease time and you can't get as much done, or it will cost more, or again, quality will be impacted. However, continuous delivery invalidates this model. It turns it on its head. Continuous delivery enables teams to deliver more value in shorter time frames and with lower cost, all whilst maintaining or even improving quality. With continuous delivery, it becomes possible to release changes safely, quickly, and sustainably. And more organizations are becoming aware of the importance of continuous delivery and the benefits that it can bring them. A recent survey showed that 65% of respondents reported that the organizations they work in have started to adopt continuous delivery. Quite an amazing number, I think. Now, when asked to rank the importance of benefits to them, the respondents on average ranked faster time to market, better quality of product, and competitive advantage as the top 3 benefits, with higher customer satisfaction and reduced cost of development not far behind. So time for another quick poll. In this poll, I'd like to know which option best describes your organization and the way that software is developed and delivered there. Again, give you a minute or two to respond there. Okay, great. So again, some interesting results. There's still some waterfall being practiced, team level agile being the greatest proportion of respondents. But it's great to see sort of the maturity of some of the organizations moving towards enterprise adoption of DevOps. The 2017 Annual State of DevOps report found that when compared to others, the highest performing software development organizations, they deployed 46 times more frequently. They took 440 times less to go from commit to production ready. They're able to recover from failures 96 times faster, and they can introduce changes that cause pipeline failures 5 times less often. So these are quite impressive numbers, and it validates the findings in previous years from this report. So what we see is that the DevOps culture and continuous delivery as a software development and delivery approach continue to prove critical in delivering value to users quickly, safely, and in a sustainable manner. Another quick question for you now. So, are you involved with applications or systems that have either handoffs to or from other teams, whether those be QA, security ops, and so on, or have multiple components that are built by different teams, or both? Okay, yep. So that's this question is really, I think, a question that hints at scale, and will lead us into what I'm going to talk about next, which is how we adopt continuous delivery at scale and some of the challenges that brings. So we do see, and that the survey that we just ran validates that More and more teams within organizations are adopting continuous delivery to help them radically improve the way they work and create value through software. But when these practices are scaled beyond small, independent, agile teams, we often see these organizations finding that they're running into hurdles that they need to overcome. The visibility and subsequently the coordination required becomes significantly more difficult to achieve when you have multiple teams that are working together to deliver parts of a bigger application or system. As scale increases, it becomes increasingly challenging to discover and maintain the visibility and the insights that allow for effective optimization of the process, of the tooling, and of the automation that are required for continuous delivery. And this really is the bottom line. I don't know who first said this, but you cannot improve what you cannot see. It's just impossible to improve something that you cannot even see. I want to talk a little now about something called software value streams. The technique of software value stream mapping, I think, holds the key to a really elegant solution to the challenges of visibility and coordination of the flow of value from idea to production. The technique has its roots in lean manufacturing. It was created there and used to visualize and analyze how information and raw materials flow through an organization and its various processes that turn inputs into outputs on the journey to deliver value. A value stream map represents a big picture view of this flow. It documents the duration of all the various processes, as well as highlighting when and where the flow is paused or interrupted, and where handoffs occur. This means that waste can be easily identified and subsequently discussed and addressed. So value stream maps can represent current state or some desired future state post-optimization. Now, historically, value stream mapping, for example, at Toyota, is referred to as material and information flow analysis. So if you see that term, value stream maps, you might see them used interchangeably. With software value stream mapping, the raw materials or inputs to the value stream, they include ideas, user stories, bugs, regulatory requirements. Now, these raw materials are realized or addressed through source artifacts that include, but are not limited to, application source code, documentation source, infrastructure source code, tests, and so on. The processing that happens throughout software value streams, that is to say, throughout the journey of an idea through to a user getting value from it, includes planning activities, the development itself, software builds, and multiple phases of deployment and testing and maintenance activities. There are, of course, other activities that happen, but these are the main ones. The output from a software value stream is ultimately some working software. And it's software that, if you're doing it right, delivers value to its users and is packaged in a delightful and lovable experience. Throughout the rest of this webinar, we're going to look at why mapping and management of software value streams is so important, and how living maps of software value streams can provide a basis for continuous optimization of continuous delivery processes and automation. Now, software value streams are typically complex. They're often more complex than their manufacturing counterparts. The level of complexity at play introduces additional opportunities for various forms of waste. This waste is often referred to as Muda in the lean movement. Now, Muda is the Japanese word for futility, uselessness, or wastefulness. The increased likelihood of waste being introduced across complex software value streams really emphasizes the need for the mapping and for the live visibility and management of value streams in order that we can maximize the flow of value on a continual basis. The most dangerous kind of waste is the waste we do not recognize. This is a quote from Shigeo Shingo, who during his lifetime became one of, if not the world's leading expert in lean manufacturing practices in the Toyota production system. And the point he makes is absolutely critical. When we can see where waste is, and when we can understand that waste, only then will we have the ability to enact the necessary change to work towards eliminating that waste. We simply cannot do that with waste we do not understand, or worse still, have no visibility of at all. So the lean movement identifies 8 key forms of Muda, or waste. Now, these forms were originally conceived in the context of manufacturing, specifically automotive manufacturing, but they're applicable to software development and delivery too. Defects are a huge cause of waste in software development and delivery, with each bug implying additional effort in rework. Overproduction in software is the act of building things that users don't want or don't need. Software value streams can have many sources of waiting waste. Commonly, this is in manual handoffs between teams and processes, or waiting for build, deployment, or test resources to become available. Non-value-add processing in software might be in the form of test sequencing that doesn't place scenarios most likely to fail up front, or in any unnecessarily cumbersome processes that detract from development team productivity. Software transportation waste includes things like manual approvals and non-streamlined approval processes with too many levels. Excessive backlogs with a lot of work that you'll likely never get to are a form of inventory waste in software, as is any code not yet delivered to production. And the greater the length of time that work is sat in a partially done state, the greater the risk of it impacting other work, and the greater the risk of it not being what the users need anymore. Motion waste refers to unnecessary human motion. This is less relevant in software development and delivery, but it could be used to describe the waste that occurs with rapid and repeated change of ownership of work. Finally, eschewed talent waste in software can be in numerous forms, including any environmental or human factors that might impact development team productivity, or the use of hard-to-use tooling, or the waste created by too much task switching, or the waste incurred by having visible metrics that are confusing to the team, or that encourage behavior that is often counter to the goals of value stream optimization. And of course, any processes or methodologies that discourage developer creativity create waste in this category. A nice acronym to remember these forms of waste is downtime. And Mary and Jim Poppendick also categorized 7 forms of waste in software development, but they all map into one or more of these traditional lean groupings. Another quick poll now. I'd like to know, how good a handle does your organization have on waste across your software value streams? Let's see the results here. So, yeah. So as I suspected, a vast majority feel that their organizations do not have a good handle on where waste is occurring and the impact that has. And I guess that is part of the reason that you've decided to join today's session. So the complexity that's inherent in software development and delivery does create real challenges when it comes to being able to see, being able to understand, and being able to optimize the flow of value across software value streams. I want to take a few minutes now to look at some of the reasons that are behind this. Okay. Firstly, the flow across a software value stream is typically non-linear. So with software built using agile methods, there are strong incremental and iterative elements. And this is very different to a typical factory production and assembly line. A car production line, for example, starts once and moves linearly until the end when it's complete. Manufacturing is typically optimizing for producing as many carbon copies of one thing as possible with a predefined value. With software, it's different. We're typically optimizing for producing one thing with continually improving and changing value. In automotive manufacturing, it would kind of be like if we had the chassis of a car traveling through the whole production line and going back to the beginning, having wheels attached to it before again traveling through the whole production line, and the assembled wheels and chassis going back to the beginning and having a body attached before again traveling through the whole production line, and repeat and repeat and repeat until you have a completed car. Then sending the completed car back to the beginning of the production line for a shinier set of wheels or a more efficient engine. And the tooling and the inspections on that production line would need to be constantly changing to ensure the production line was kept working and was delivering the necessary level of quality. With continuous delivery and its emphasis on amplified and automated feedback loops, change is expected. It's more than expected. It's embraced. It's embraced as an important enabler in ensuring a focus on delivering valuable outcomes with high quality, as opposed to simply maximizing output to a fixed formula. When we're creating software, as defects are found at any given point in the value stream, entirely new inputs in the form of changes to code to fix those defects are created and delivered. And with software factories, there isn't just a single production line. Ephemeral pipelines are created to validate changes to short-lived feature branches via pull requests. And feedback just doesn't come in just the form of test results. Every delivery is potentially exposed to users whose needs change over time, and so are continually providing feedback in the form of requests for change. With software, the product is never actually finished. The second reason is that software value streams have constantly changing raw materials. With a factory production line, the exact same process and automation and inspection is followed every single time. Every step on the assembly line takes the exact same raw material inputs, applies the same processing repeatedly, and creates the same outputs over and over again, hundreds of thousands of times per year. With software, the issues being worked on are always different, whether that's work on delivering new value or fixing defects discovered with existing products, or, any changes in regulation or anything like that. Effectively, every new thing being worked on is different to the last, and it's different to all the issues that have been worked on before. So therefore, the input, which is typically a change in code, is also different every time. And the inspection, the testing, is continually being extended to ensure that the new inputs are being validated to ensure they meet desired functional and non-functional quality parameters. And the numerous environments on which the software is deployed throughout the value stream are continually evolving. The third challenge is that software is becoming inherently larger. Now, contrary to what this picture suggests, it's not through traditional growth of a monolith, but more and more it's through loosely coupled microservices architectures, allowing for applications that are built as systems of systems. The way it is with small, independent and autonomous agile teams is that they usually have clarity of purpose and nice, confined individual ownership of components. Their work is typically focused around a single software pipeline. Every team in this model has typically good visibility into specific inputs, pipelines, and dependencies. Everything's pretty good in this little vacuum. But as we scale, we find we have many teams that are working on parts of something much bigger. We not only have cross-functional development teams, but we also have other domain-specific teams that play key roles in the flow of value throughout the software delivery lifecycle. For example, release teams or security teams, operation, performance teams, and so on. Often, we have components that are handed between such teams to support specific processes along the way to releasing. And we also have inherent dependencies between teams due to the application architecture, with components or frameworks or services that are used by other teams downstream. For embedded software, cyber-physical systems, which we increasingly rely on in our day-to-day lives, complex interactions between hardware and software must also be considered. And as this scale increases, we really start to lose visibility. It becomes much more difficult to see what's going on. It's hard for people upstream to see what impact their work has downstream, and projects and teams that are downstream have very little to no visibility on what's going on upstream. Fourthly, Complexity is heightened because a single application might very well be built by geographically distributed teams. The time zone differences create global dependencies. They create handoffs and they create waiting, which makes it more challenging to gain and maintain visibility into the process. And beyond just geographical boundaries, the software supply chain may even cross contractual boundaries within and beyond company walls. Finally, in the course of building software, we create a lot of information, a huge amount, in fact. And this information is in many forms. It's part of the products we're building, for example, the source code. It's also information used to orchestrate the delivery of software, for example, our work items or issues, our build jobs and pipeline definitions. And it's information that is created as a byproduct of the continuous delivery process, such as build and test results and metadata. Now, a best of breed tooling approach over the years has just naturally risen to the fore. But of course, this has led to a situation where all of this information is located in different tools and systems. So another poll, having talked about some of these challenges, I'd like to understand which ones do you see as having greatest impact in visibility at your organizations? And I'm sorry, this can only be a single choice question because I know it's more nuanced than this in reality. Very interesting. Okay. So nonlinear flow, scale, and information dispersal are so most impactful for the respondents we have. Good. Thank you for that. Now, because of the complexities that I talked about, mapping software value streams is unfortunately not a simple activity. It's difficult to create and visualize context between the different teams, between the information in the various tools, and the part that those teams and those tools are playing in the bigger picture of application delivery. And if we can't see that big picture, and if we don't have the right context, then it becomes really difficult to effectively optimize. For example, in Jenkins, you can see individual jobs and continuous delivery pipelines in isolation. Likewise, you can look at work items and you can look at issues in Jira, or you could go into your SCM system and look at the Git commit details. But there's been no easy way to view all three in context together. A one-time exercise to map value streams will certainly be valuable, but at best it represents a static view of the software delivery process. But software development and delivery is a highly dynamic activity. Static maps just cannot provide the visibility into the current state of a software value stream. And they cannot enable an immediate understanding of what changes are currently being worked on and the blockages that are impacting value delivery and creating waste. And of course, when you try and map them out, often you get something on paper that is pretty difficult to understand, as you can see from this example on the page. So what's needed is a way to get visibility in real time across the software development lifecycle. This is necessary so that you can see, so that you can understand, and so that you can measure the flow of software across your value streams. And that is where CloudBees DevOptics comes in. So DevOptics makes it easy to map and then actively measure and manage your value streams. It acts as a single source of truth to analyze and continually optimize the flow of value. It reduces the reliance on manual, effort-intensive, and error-prone data collection from multiple sources for reporting. And it allows teams to collaborate in real time via views and metrics of their value streams that provide much needed context. The value stream view in DevOptics models the end-to-end continuous delivery process visually. Entire applications and systems of systems can be decomposed into an easy to understand real-time view of value flowing from idea to production. Tickets and their associated code changes and generated artifacts can be tracked across the different teams, processes, and automation in the value stream. And getting started is simple too. Mapping a value stream in CloudBees DevOptics allows Jenkins pipelines across different masters to be related as a series of gates that visually depict how issues and their associated commits flow from start to end. There's a visual editor that makes this really easy to do, but DevOptics also allows organizations to manage value stream configuration as code via a simple JSON format. Once a value stream has been mapped out, DevOptics provides critical visibility into context between Jenkins jobs and pipelines, Git repositories and commits, and Jira tickets. It allows you to drill into any of these for further detail, whilst also providing a big picture that helps us visualize entire value streams end to end. Root cause analysis becomes much simpler when you can see the specific changes that have caused failures and understand the details of those changes in the context of others. The real-time visibility that the value stream view provides in CloudBees DevOptics helps in a lot of ways. Related information from across the software delivery lifecycle is displayed in context with easy navigation to the source. Questions about the current state of delivery can be asked and answered, such as where is a given feature in the value stream? Has it reached staging yet? When will it reach production? Where is all the work I've delivered this week or in the last month? What caused this failure in production? What changed since yesterday? Did the fix make it to release? What is it that's choking our CD process? Why does it take so long for a change to be validated? What issues are parked in a given phase? What is blocking features from progressing past a given phase? Different teams can gain visibility and context of the real-time status of dependencies they have on other teams and that other teams have on them. Failures and blockages are immediately visible as they happen, and the root causes of failures are easily diagnosed because context is provided with accurate, up-to-date information from across the software delivery lifecycle. There's built-in search and filter capabilities that make it easy to find issues by name, ID, assignee, and help teams focus in on where any piece of work is at any point in time in the software value stream. So we know that it matters how teams create software. We see that the companies that are adopting continuous delivery across their organization are giving themselves an advantage in their ability to rapidly innovate. And we know that it's important to also gain visibility of how value is being delivered across your value streams. Static snapshots of value streams aren't so helpful with the constant state of change in software development and delivery. Real-time visibility is incredibly important with software. But it also matters that we measure how we create software. It matters so that we can learn and adapt in order to continually improve that ability to create software. If you recall, I talked earlier about how the 2017 annual State of DevOps report found that when compared to others, the highest performing software development organizations, they deployed 46 times more frequently. They took 440 times less to go from commit to production ready. They're able to recover from failures 96 times faster. And they introduced changes that cause pipeline failures 5 times less often. These organizations with those numbers are the organizations that embraced continuous delivery. Not only embraced it, but have dedicated themselves to mastering it. It's becoming more and more clear that the organizations that measure and optimize continuous delivery across their software value streams are creating a competitive advantage. Beyond real-time visualization of software value streams, DevOptics also provides automated measurement of the key 4 continuous delivery metrics that are popularized in the aforementioned State of DevOps reports. These are the metrics that I mentioned earlier that provide important leading indicators of IT and organizational performance. Remember, you can't manage what you don't measure. And DevOptics doesn't only provide metrics at the value stream level. Insights into the usage of the platform also help with ensuring that Jenkins is optimally supporting teams working across your software value streams. And DevOptics can help with identifying and tracking the 8 forms of Muda, or waste. Defects and the remedial work to address those defects are easily tracked visually in real time across value streams. New defects discovered at any point in the value stream are immediately visible. Product managers and executives can see all of the work flowing through the value stream at any point in time historically and ensure that gold plating is avoided. Manual handoffs between different teams and across different Jenkins jobs are readily apparent, and insight is provided into waiting times and waste caused by unavailability of underlying resources in the CD platform. Having real-time visibility of the end-to-end value stream, coupled with the insight provided by the CD metrics, make it much easier to identify problem areas that are impacted by non-value-add processing. Phase and weight analysis capabilities provide visibility into transportation waste caused by manual approvals. With DevOptics, it's really easy to see how long any piece of work across the value stream has been sat undelivered to production or in a given gate. So this key aspect of inventory waste is easy to track. Visibility into work items and tickets and their ownership can help track waste that's created by motion of ownership. And eschewed talent waste is actively avoided by providing teams with CD metrics that are the key leading indicators of organizational performance, focusing improvement efforts on the right things. We're continually enhancing DevOptics to help organizations in identifying and ultimately eliminating as many forms of value stream waste as possible. So, how important is this? Well, for too long, IT and software development functions have been seen as a necessary evil. You know, they've been viewed as one of the tools that businesses could use to achieve their goal. They've been viewed ultimately as a cost center. Board discussions about IT and software mostly centered around cost reduction. How can we achieve the same with less? How can we free cash and resources for core functions? But as it turns out, the mavericks, the ones that are redefining industries through software, they don't see it as a bottom line exercise. They see things quite differently. And their board level conversations also sound very different in this regard. Their conversations are more centered on the value that their software delivery capability can bring to the business, on how being better at software will give them a competitive advantage. They see it as a top-line contributor, which really does make a lot of sense. This requires, however, organizations to embrace change, necessary change. And there are some reminders of what happens when necessary change is not embraced. In 2007, Nokia recorded 7.2 billion euros in net profit. This was the same year that the iPhone was launched. And by 2012, Nokia's sales had collapsed and it posted losses of more than 3 billion euros. So evolution is required, but make no mistake, it's definitely hard. The story of Kodak is similar. They did not embrace software-driven innovation that came along with the digital camera ecosystem. They went from market leaders to also-rans. The reality is that every company that wants to compete must become good at producing value through software. This quote from General Eric Shinseki conveys the message wonderfully. If you don't like change, you're going to like irrelevance even less. So in summary, it matters how you create software. We see that organizations who maintain and enhance continuous delivery as a core competency consistently outperform those that do not. But as we scale, it becomes more and more difficult to do continuous delivery well. Numerous challenges are faced as we scale that mean it's really very easy to lose sight of the flow of value across multiple teams working in the context of larger applications and systems of systems. If you do lose sight, you can't really know where or how to improve things, not in a reliable fashion anyway. You just cannot improve what you cannot see. One-time activities to understand how value flows through an organization's software delivery capability can only provide so much value. The constant state of change in software development and delivery means that real-time visibility is critical to optimizing the flow of value. Part of optimization of software value streams is gaining an objective understanding of current performance of those value streams. You cannot manage what you do not measure. These challenges, we feel, are elegantly addressed with real-time visibility across software value streams. And CloudBees DevOptics provides that visibility and gives the awareness and understanding necessary to help optimize your ability to rapidly innovate with software. Thank you very much. I'd like now to be able to have the opportunity to answer any questions you may have.
Great. We have a few questions here. First one, does the solution work with OSS Jenkins, or is it limited to CloudBees Jenkins only?
Thanks. So it works actually with any flavor of Jenkins, but whether it be OSS or CloudBees Jenkins, but it does need to be a Jenkins version that is above, I think it's 2.73.3.
Great. Why doesn't the product look like a traditional value stream map?
Yeah, good catch. So a traditional value stream map is really great at describing the flow of information and materials in traditional contexts. It's a very formal syntax, but I don't think it's necessarily the best way of showing what's happening in real time across complex and highly dynamic software value streams. What we've tried to do with DevOptics is to make sure that the key information that supports decision making across the SDLC is as easily consumable as possible.
Okay. We have a question here. We use Scrum and have burn down charts, which show us what value we have delivered at the end of each sprint. What would this give us that we don't already have?
Okay, good question. Well, firstly, burn down charts, I think, they're only as accurate as the input you provide to them. So manual input is going to lag behind the actual status of the system. And it's, of course, at the mercy of team members updating the status of tickets. Secondly, I think those charts, they're not intended to map out your process. So you end up being, I think, quite blind to areas with waste or areas where you could potentially improve efficiency. Burn down charts in that respect, I think, could potentially give you a false sense of success or improvement without understanding that aspect of waste and potential for optimization.
Great. In reference to inventory, one of the Muda, how do you maintain shorter backlog given the rapid and shorter delivery cycle?
So I think this is less a question of visibility and more a question of modern product management practices. It requires discipline to do that. The reality is that shorter backlogs are things that you have a lot more confidence in that you're going to deliver. And ultimately, maintaining backlogs with things that are further out, that haven't been validated through constant discovery and user feedback before they're being delivered, they're ultimately a waste of time to even be thinking about them. So I think that's less about visibility and more about maintaining the product management discipline required in order to keep the team focused around what's important in the short term.
What tools and integrations do you support today, and what tools and integrations are you planning to support in the future?
Yeah, so right now DevOptics integrates with Jenkins, with Jira, with various different Git systems, including GitHub, Bitbucket, GitLab. In the future, we want to integrate with various tools from across the SDLC in different areas, things like ServiceNow, New Relic, SonarQube, Black Duck, various different tools from across the SDLC.
Okay. We have a question here from someone who says they have a monolithic application with a single branch for each new development and are looking to move to Agile DevOps methodology. Their question is, what kind of branching policy should be adopted or changed in order to follow DevOps principles?
Sorry, can you just repeat that question? It broke up a little bit on my end.
Yeah. They are asking about a monolithic application that has a single branch for each new development. And they're wondering about what kind of branching policy should be adopted or changed in order to follow DevOps principles.
There are a few that would work, and it's kind of dependent on the organizational structure, the team structure. But a single master branch with the teams working on short-lived feature branches and collaborating around pull requests is typically a model that works well.
Okay. We have a question here. Only some of our teams are just starting to adopt continuous delivery. Are software value streams still beneficial for us?
Yeah, absolutely. A value stream mapping exercise, I think, is going to be beneficial regardless of the underlying process that you have currently. The resulting value stream map, it will help you expose waste and inefficiencies. You can then sort of look to design a future state where you want to be after you remove such waste. You may find out that you end up adopting continuous delivery pipelines as a result of that.
Okay. We have a few more questions here. This question is Scrum or Kanban for DevOps?
Good question, and I don't think there is a right answer to that, to be honest. I've never actually met any organization or people working in teams that are adopting Scrum as is, sort of by the Scrum Bible type to the letter. There's often sort of hybrid approaches, and again, it's one of those questions that is really dependent on the team structure, the team location, whether they're distributed, whether they're co-located. There's a lot of different factors that are going to weigh into that decision. Continuous delivery is going to be compatible with either of the either Kanban or Scrum. There's certainly nothing to say that the Scrum approach of making sure you have a potentially shippable increment at the end of a sprint means that you can't actually deliver multiple things during that sprint. So, yeah, it's going to be dependent on the organization, but either can work.
Okay. We have one more question here. We're a small company and don't have a lot of the complexity you mentioned. Can DevOptics provide much value for us?
Yeah, it can. I mean, the reality is that with DevOptics, it's true that as scale and complexity grow, visibility is going to be more and more difficult. Having that real-time view of where things are, it's useful at any scale, I think, and the analytics and insights capabilities still allow for objective benchmarking of your software delivery capability. So you can set goals and track improvement over time. So certainly, I think it just becomes more and more important to do that as you scale. But yeah, you can start at any level, and it could be argued, in fact, that starting whilst you're small will set you up for being able to scale more effectively.
Great. Well, do you have any last words as we wrap things up?
And no, I just want to say thank you to everyone for taking the time out of your busy schedules to join us for this today. And yeah, feel free to reach out to any of us if you want any further details of anything you've seen today.
Well, thanks very much, Ben, for a wonderful presentation today. And I also want to thank today's sponsor, CloudBees, for providing the DZone audience with a great webinar. Lastly, thank you to everyone who joined us today. We hope you learned something new that will help you in your developer career. Have a great day, and we'll see you next time.